Hey students, here is your homework from this previous week, and I thought I might go ahead and go over how you would get this done, show you how you would use Excel to do this. This kind of really follows up from our previous weeks, but this also helps review for the exam you have coming on. So also talk about content, terms that we were looking at. All right, let's take a look. Here's your homework. Now what you're given is a opportunity cost of investment. You would like this investment to earn you 20% return. The initial investment cost you $100,000 in the very beginning, and then you've been given net cash flows across 10 years. So the question is, how do you calculate net present value? Is this a good decision? And how do you calculate IRR, internal rate of return? So again, we want to kind of review a little bit and go over how to do this. Now, there's a couple of approaches that I've shared with you before, and I'm going to go ahead and do this part both ways so you can see it slowly. All right, present value. Remember, present value is a discounting concept. We're looking at money in the future and how does that relate to the value today? Because in today's money, that's the really only way you can understand what a dollar's worth. If I know what a brand new truck cost me today, that is what a truck cost. If I want to try to think about what does a truck cost in 25 years, I really don't know how to do that. I might come up with some ways to get that done. But when you're talking about the value, you understand today's money. You know what a gallon of milk costs. You know what a dozen eggs cost. You know what your salary is. And you know what a new truck costs. So it's easier to talk about money in terms of the value today. And that's called present value or discounting. Now, future value, compounding, has its place. But this case, we're talking about, is this a good investment? You're always looking at what's it worth in today's money. And that's what I can use. So let's start with each year one at a time. Time value 0 is the value of today. So what is the value today of $100,000 paid out today? It's the same $100,000. There's no need to discount. Now, if we start discounting, we can use things like equal sign present value, which we've gone over. So what is the rate? Well, the rate is the 20%, comma. What is the time? The time is 1 year, comma. What is the payment? There is no payment. It's one value, and it's a future value of that. Now, I'm always going to put a negative in front of, that's not a negative. I'm always going to put a negative in front of the value. That way my answer comes out to be positive, then I can then use that. So I hit enter. 12.5. If you got to wait a year, it's worth 10,416. Now I'm going to double click and see what my formula uses. That C2, that rate up there, I don't want that to change. I'll put a $sign in front. The C7 I want to change, and the B7 I want to change as I go. So I think I can just hit enter there, and those values, if I copy and paste, flow all the way down. So 28,000, you got to wait 2 years is really 19. 32, you got to wait 3 is really 18. 32, you got to wait 4 is really 18. Let's double click and see what it's using. And it looks like it's using the same rate. It drops down. That's perfect. So you can see here, these $32,000 deals in year 3 and 4. Why is it worth even less if you keep going? That's because you got to wait a year. 30,000 is only worth 12. 15,000, you got to wait 6 years to get it. It's only worth 5,000 today. And finally, you got a big 65,000. Well, that's only worth 10 today. If you add all these up, including what you got to pay up front, you actually end up a little bit short the negative value. Now, NPV can be done all at once. You don't have to do it one at a time. Equals NPV, and it's going to ask you, so what is the rate? You're going to say 20%, comma. Now, notice here it says, what's the value at 1, 2, 3? You need to start with year 1, highlight all the way to the end, close parentheses, hit enter. 50,000 is what all this adds up to, and I have used the wrong numbers. That actually is the set of numbers over there. So it brings back you $98,000. Double click, but I forgot to add, I didn't add it. And you got to add it because there's no discount. It doesn't need the time value of money part. So it starts with period 1, goes all the way to the end. But if you come back and add that 100,000 to it, you can see that it's negative 1,110. That's the same negative we got there. So is this a good decision? No, it is a bad decision. Now, NPV, or IRR, actually helps us out with this same decision. We've already said it's bad because that's a negative NPV. But if you come here and do IRR, equals IRR. It's already got it in the formula. And it just says starts with the values. So actually you can start with the values here at time value 0 all the way. As soon as you hit enter, it shows you this is earning 20%. But if we get a little bit more detailed with the decimal here, it's actually earning 19.69%, but we said we needed 20, so this deal won't work out at 20%. Now, if you come and look at this, you might say, well, then how do you make this be a good decision? Well, a couple of ways. One is that the risk is not as high. If we came in here and said, you know what, we really probably only need 15% return, this thing's about to look profitable, once again, because it earns 19.69. So if you think you only need 15, then this is a good decision. But what if you go back and say, no, 20 is more appropriate. This is pretty risky. How else could you get this done? If you could borrow the money, then you could take the 100,000 that's negative up front, and you could drop that to, let's say, 20,000 negative. Now that 20,000 negative, if I drop that 20,000, hit enter, then that is a great decision now it looks like. But of course, that's 80,000 you have to pay back. So what you would do is you would do an $80,000 loan, and then that $80,000 loan would have payments, and we would factor those payments in to be in these years, which would lower the amount of money we had because we had to make a loan payment. But if you could borrow the money at, let me back up where we were, if you could borrow the money at anything better than this 19.69%, then it will actually pay. And so in many cases, that's why borrowing takes place. All right, so what are some of the terms you need to learn out of this? Well, what are some of the tools you need to learn? Hopefully one is how to use Excel and calculate these values. That'll be important. What else do you need to understand? You need to understand things like present value. That's discounting. What affects present value? Time and rate. They all negatively affect it, just like we went over in the videos from last week. What's another term? Future value or compounding, and that relates to, in this case, time and rate. But it's the opposite effect. The more rate you have and the longer time you have, the better future value you'll have. So really, compounding is looking out in the future and trying to look at that value. Discounting is looking back at today's values, and those are just common time value of money terms. Applied to this is called net present value, and that actually helps us look, is this a good idea or a bad idea? Now, something else that we talked about in the last week is something called payback period. And that's something new I want to share with you here. Not new, something I want to show you here as well. Payback period looks at how long it takes for us to get our money back. So if I come in here and look at this, and let me move over here and do payback period. Payback period is going to say, well, it starts out with the 100,000 that we have up front, right? That's what we got to pay out. Well, what you can do is write some simple formulas here. So here are our years, right, that we had before, and that's going to be those numbers right there. So in year, let me see if I can move this stuff around here. In year one, let's see here, I'm trying to get that color off of there. There we go. There we go. In year one, those are not supposed to be. Oh, let's see here. I want a format here. I don't want any dollar format at all. There we go. So in this numbers, we're going to see how long it takes to get our money back. How much money we have left over. So in this year, we have 100,000 that was out. We brought 12.5 back. Now we're short 87.5. In the next year, we had that plus we got back 28,000. That got us in better shape. And you can really just keep that formula going all the way down. And you can see here in year 4, actually in year 3, we are short 27.5, and then in year 4 we get another 32. So equals, you're going to go ahead and stop that. Equals, sorry, you go through here and divide that out by that 27.5 by that 32, because we really need 0.86 of that year. So that would be 3.86 years that we have in value to get paid back. So that's actually the last part of that. Now, sometimes when we do capital budgeting, that's what this whole thing is called, there is something called the simple rate of return. Simple rate of return is this idea that we take the average income and we divide it by the initial investment. Now, some people do this because it's simple and it's easy to do, but it's got lots of problems. In fact, payback period, what's the problem with payback period? This does not account for risk. That's its problem. And so payback period, the negative is does not account for risk. So that's why this approach is better. But it's used, and so I want to go ahead and make sure that I highlight it. It doesn't account for risk. What is the advantage of simple rate of return? Is it's simple, but it does not account for risk or time. And that's its problem with simple rate of return. But it gets talked about, so I want to show it to you. Simple rate of return is also commonly called SRR. All right, average income, that's easy to get. Just equals an average, and the average is in year 1 we get this, and in year 10 we get this. And so all across the whole time of the investment, you get $24,520 back. Now, the initial investment is $100,000. So actually, a simple rate of return here, SRR, is just equals, is divide the average income. So every year on average, you get $24,520. Divide it by what it initially cost you, and it looks like you get 24.52% return. But this has got a huge problem with it. One is it takes you 10 years to get that. That's not very good. It also doesn't account for how risky this is. The money is how we predict it, but it's really risky. So we could be way off here. So we need to apply a risk to this, and you don't see that at all in simple rate of return. You really don't see that at all in payback period. So payback period, simple rate of return, they get talked a lot about in capital budgeting. They really are very inferior for those reasons. That's why we do things like net present value and internal rate of return. They really give us a clear picture of capital outlay of money called capital budgeting, and that's why we talk about this section. Hopefully this video helps you see how to do the homework and also shares with you the last bit of topic and content we have for this section. Thanks.